all started on 30th July 2020 when Perseverance, made by Jet Propulsion Laboratory, started its journey to our neighbor, Mars. But for what exactly? What questions would we get answers to? Our rovers have been here before, right? Curiosity rover landed on Gale crater looking to identify and searching for habitable environments on Mars and was able to confirm that liquid water was present on Mars for an extended period of time, long enough to deposit sediments on the floor of Gale crater to generate and create clays that are found inside some of the units in Gale crater. We also found complex organic molecules there. Water and complex organic molecules are the two main ingredients to make a habitable environment, so that life would have possibly started to take form on Mars. All of that led the way and prepared us to design Perseverance rover, our first astrobiologist seeking the signs of life on another planet. But what exactly the Perseverance would be doing there? What signs of life is it searching for? What technologies would we be testing out there? Are we getting close to stepping our feet on Mars? Perseverance rover has four primary goals. First, to determine if Mars ever supported life. Second, to understand the processes and history of climate on Mars. Third, understanding geology of the red planet. And fourth, to prepare the way for us, humans. Goal 1 is predicted on the idea that Mars and Earth may have been relatively similar worlds during the early histories, and as life arose relatively early on the Earth, whether life ever arose on Mars is the key question. To get a better idea of what we are searching for on Mars, let us look at some of the oldest proofs of life on Earth. We'll have to go to Australia for that. The oldest definitive fossils that we know about are in Western Australia. They are stromatolites formed by mats of bacteria 3.5 billion years ago. Stromatolite deposits are formed by sediment trapping. The microbes are active on the surface layer of the stromatolites, while the underlying buildup is the transformed into stones remains of the former microbial surface communities. After we have already confirmed habitability, we are essentially looking for these microbial fossils and organic matter as evidence of life. Look at this picture. This picture shows the Jezero crater where our rover landed. We can see the remains of an ancient delta in the crater. This evidence shows the presence of water there and high chances to find signs of fossilized microbial life. Our second goal is to understand the processes and history of climate on Mars. A better understanding of Mars' current climate will help scientists more effectively model its past climatic behavior. To do that, we'll need detailed weather maps of the planet and information about how much dust and water vapor are in the atmosphere. Monitoring the planet for this information over one full Martian year, that is 687 Earth days, will help us understand how Mars behaves over its seasonal cycle and help us understand how the planet changed over millions of years. The Martian polar region's layered terrain also holds clues about the planet's past, much like the rings of a tree provide a record of its history. Our Mars mission still have to answer a number of questions, like when and how were these polar layers deposited? Was the climate of Mars ever like that of Earth? And if so, what happened to change the planet into the dry, cold, barren desert as it is today? Our goal 3 is related to catching samples. Goal 3 seeks insight into the composition, structure, and history of Mars as a planet through a deeper understanding of its surface and interior. One of the coolest features of Perseverance lies in its instruments and plan of sample collection. To really unlock the secrets of the red planet, we have to bring the samples from Mars back to Earth. Our Perseverance rover is well competent to do that. It will drill soil and rock, collect samples, put them into small tubes, seal it, and put it on the surface to provide a target for next mission, Mars Sample Return Mission, which will hopefully develop in next several years and get samples back by 2031. We'll get to know the answers to the questions like how did Mars become the planet we see today? What accounts for the differences and similarity between Earth and Mars? And how is the geology of our neighbor? Eventually, we humans would want to get to Mars, but taking astronauts to the Mars and bringing them back is a huge engineering challenge. Perseverance will test technologies that would help sustain human presence on Mars someday. But what technology would we be trying there? And this is our goal number 4. Its Mars Oxygen In Situ Resource Utilization Experiment or MOXIE instrument will demonstrate a way that future explorers might produce oxygen from the Martian atmosphere for propellants and for breathing, because it would be much more efficient to make oxygen on Mars than to take it from Earth. A weather station on the rover, known as the Mars Environmental Dynamics Analyzer or MEDA, will help study the shape and size of the dust in the atmosphere. This knowledge will help shed light on how Mars dust may affect human health. The instrument's measurements include all kinds of weather related data like wind speed and direction, temperature and humidity, and the amount and size of dust particles in the Martian atmosphere. To further our understanding of the temperature conditions on the Mars atmosphere, the mission will also collect information during its entry, descent, and landing phase using MEDA. This suite of sensors is attached to the heat shield and back shell and collects data as the spacecraft plunged through the atmosphere. Apart from all this, we will also be taking flight on another world. The Mars helicopter Ingenuity is a technology demonstration to test powered flight on another world for the first time. It is hitching a ride on the Perseverance rover. A series of flight tests will be performed over a 30 Martian day experimental window that will begin sometime in the spring of 2021. The helicopter flies on its own without human control. It must take off, fly, and land with minimal commands from Earth sent in advance. The helicopter may fly for up to 90 seconds. It is powerful enough to lift off in the thin Mars atmosphere, less than 1% the density of Earth's. So it had to go through a lot of tests and a lot of simulations before getting to Mars. After a 7-month-long journey, NASA's Perseverance rover successfully touched down on the red planet on February 18, 2021. We are ready to search for life on another planet, and Mars is waiting to be stepped upon. I really thank you for watching.